So today's course is an introduction to quantitation and reporting limits, and we call this Reporting Limits 101. What over today are the definitions of quantitation limits, the water ambient monitoring programs reporting limits requirements, briefly about determining program and project reporting limits, how to work with laboratory when your project or program has specific reporting limits, for communication of reporting limits. And then I have some comments on reporting in the context of reporting limits. I'll give you a brief introduction into some new developments from EPA. Finally, we'll go through a conclusion, and I'll give you a preview of Reporting Limits Class 102, and if folks are interested in that, then we could develop that course. The thing that you're going to walk away with today is a general understanding of the common quantitation limit terms, understanding of the differences between the quantitation limits. I want you to know what the SWAMP requirements are, and I want you to walk away with a brief introduction to determining reporting limits and tips for ensuring your labs can hit those. Some of the slides have a lot of text, and they have websites. I'm not going to be going over a lot of that text. The reason it's in the slides is so that you can use this as a reference for later. So I will provide the slides as a PDF to Eric, and he can post that. So if you folks want to have those as references, you'll have it in there. The first thing I want to do is give you a preview of where we're going to be in about 30 minutes, 35 minutes. Because in the beginning of this presentation, I'm going to go through a lot of boring definitions because you need to understand those to be able to then use them to develop reporting limits. So this slide you're going to understand fully probably in about 30 minutes. This slide. And in this slide we have both terms and numeric establishment for those terms. And we're going to go through and we're going to develop this slide together, actually, and you'll understand it. So I'm telling you that now so that you'll sit with me through all this sort of boring jargon that we're going to get into right now, which is the definition of quantitation limits. The first one that we're going to look at is the method detection limit, MDL. And what to remember with the MDL is that this is a combination of sample prep and analysis, so the method, the laboratory that is running the MDL. Those slides with a lot of text, which I'm not going to go into. But I want you to know about the MDL, the method detection limit, is that this is one of the quantitation limits where we actually have a U.S. EPA definition. Definition for method detection limit is actually in the Federal Register. And the procedure for determining a method detection limit is in the Federal Register. What we'll find out later is some of these terms are used differently in different contexts. And this is one of the ones where we do have a U.S. EPA definition. And what that definition is that the detection limit is the lowest level that we see a signal above 0. Well, how does the laboratory determine the method detection limit? And again, this is a very specific procedure that's laid out in the Federal Register as to what the laboratory is supposed to do. They are supposed to run 7 replicates and using statistical tests what the method detection limit is based on the outcome of those 7 replicates. Am I expecting you to remember this? In your day-to-day jobs, what's important for you to know about method detection limits? I'm not expecting you to remember they 7 replicates and they spike them at 1 to 10 times the MDL. What I'm expecting you to remember is that the method detection limit has an EPA definition and it's the lowest level signal that's produced. To remember with this one is the signal is detected. And we're going to talk about in a few minutes how that's different from some of these other quantitation limits. It's the method detection limit, or the MDL. That slide in the beginning that had all of our different quantitation limits on it. So now what we've talked about is the method detection limit. And we're starting at the lowest level of concentration with analytical chemistry. And we're going to move up the concentration as we move up with these quantitation limits. Now, I did not understand what I just said. Don't worry about it because I'm going to explain that more fully as we go through when we try to determine how to set a reporting limit later in the talk. So right now, what I want you to remember is that method detection limit means the signal was detected. Move on to our next quantitation limit, minimum level. The minimum level is different from method detection limit. The minimum level takes into account the method and its method detection limit and multiplies it by a factor that was determined by CPA. Frequently, in most cases, the minimum level is also the lowest point on the calibration curve analytical process. Now again, like sitting there at your desk, you're thinking, this is going one ear and out the other. I don't understand anything what she's saying. Hang in there because it's going to come together. Another one where we have a US EPA definition. So EPA has a defined definition for minimum level. It's not in the Federal Register, but it is in many EPA methods. So in several EPA methods, you will find a minimum level. I think in most of the EPA methods, you will not find a minimum level, as it was a newer concept introduced in the probably mid-90s, I think. What's important today for us to remember about minimum level? It's different from the method detection limit because now we have a signal that is quantified. The level is determined by a statistical equation that was determined by EPA, but it's also usually the lowest point on the calibration curve. And so we see the two side by side here. We have method detection limit, and with method detection limit, the key is that the signal was detected. With minimum level, key was that the signal was quantified, and we are moving up in our concentration level now. And I just want to reiterate that if you're not understanding this or you are lost, hang in there, because when we go through the exercise of determining a reporting limit, I think that this will make sense. You need to have this background to be able to do that. So I'm going to go back one slide for just a sec. We have minimum level where our signal is quantified, associated with a number, and we have a signal that's detected. The low level greater than 0 that method can hit. We're going to move to our next definition, and this is practical quantitation limit. Now, I have a lot of issue with this because there is no one definition practical quantitation limit. agencies define it differently and folks use it differently in practice. Many folks define it as the instrument, so the method, plus analyst. Analyst, I really do mean the individual person running the samples, and then a factor. So what you want to do, if we were using that definition of the practical quantitation limit, what a laboratory does is they look at the method detection limit, take into account their own instrument, how old is that instrument, how often is it maintenance, and the analyst. So does the analyst have a lot of experience, or is the analyst relatively new? And then they subjectively pick, based on that, a factor of anything from 2 to 10, and multiply that by their method detection limit to come up with their practical quantitation limit. So you can understand a system like that would make a quality assurance person like me very nervous. It's very subjective. It's not repeatable, and so on. Or another way that's define the practical quantitation limit, and I love this definition, is 3 times the lowest point on your calibration curve. And it's simple to understand. When you run an instrument, you run a calibration curve, and that lowest point that's run through is multiplied by a factor of 3. So that would be equivalent to your minimum level. Your minimum level will be multiplied by a factor of 3, and that is your practical quantitation limit. So I have supplied several slides with text of different definitions that are given for this. But what I want you to remember with practical quantitation limit is there is no one definition. There's no US EPA definition that's followed by everybody. And so folks do use this term. You have to first ask them, how are you defining practical quantitation limit? Seeing nowadays is that common practice with commercial laboratories is for them to use that 3 times the lowest point on the calibration curve, that last bullet point on this slide. Again, you can't count on that. So you do to ask how the practical quantitation limit was derived. So before, when we talked about the method detection limit and the minimum level, we talked about that the method detection limit was a signal is detected, that lowest point greater than 0 that the method is able to detect. And then we talked about how the minimum level moves us up in concentration and allows us to quantify the signal because it is or greater than the lowest point on the calibration curve. Where are we at with practical quantitation limit? With practical quantitation limit, with that first definition, where frankly, if anybody's using that definition, I would suggest that you just allow them to do that and ask them to use some other quantitation limit. But if they are, the signal is assumed to be quantified. Now, using the other definition, the 3 times that lowest point on the calibration curve, now we're moving into yet a different realm because we have a signal that's quantified with the ever-important statistical rigor. The practical quantitation limit, if we use that second definition, moves us into a realm of even more usable data. So that are at 3 different quantitation limits. Method detection limit up there in your upper left. And with that one, US EPA defined, and the key term we want to remember with that is that a signal is detected. With minimum level, which also has a US EPA definition, and with the first definition of the practical quantitation limit, we are moving up a level from the method detection limit. We now have a signal that is quantified with that second definition of the practical quantitation limit, we move to yet a different level of data usability in that our signal is quantified with statistical rigor. I have it in a list because I know that everybody sort of learns differently, and so I'm kind of trying to really beat everybody over the head with this, so hopefully we'll remember it. I put it to you in a graphic example, and here it is in a list. It's the same information: MDL detected, ML quantified, PQL quantified, and if you do it 3 times that lowest level standard, it's quantified with statistical rigor. So let's go on to reporting limit. What is different about the reporting limit than the other 3 that I've just introduced? The answer is you decide this one. It's not determined by the method. The other 3 that we looked at are determined by the method. There's limitations based on the instrumentation, the prep procedures, and so on. The limit should be not solely based on data use, but primarily based on data use. And the reporting limit is set by the data user based on the data use. And how do we set that? We look at the action limit. So with our data, what point is important to us? So, for example, are we working with a water quality standard? Are we working with an assessment threshold? Do we need low-level results because we're going to tie it to toxicity testing? The data use is what's going to set the reporting limit. Another one where we don't have a US EPA definition and one entity that tells us, here's how you do the reporting limit. And I want you to be really careful about this because this is, I think, the most misused term on a day-to-day basis, at least in my job. Frequently, laboratories will tell you, oh, our reporting limit for such is X. What they really mean is their minimum level most of the time. Really, it's usually the lowest level on the curve. But is that a reporting limit, and then would that be useful for you in your project? It's apples and oranges at that point. So I want you to be careful of this particular term, reporting limit. Reporting limit is set by the program or the project, not by the laboratory. The important thing with the reporting limit to remember is that it's statistical rigor in order to be used in reporting. Things among tying it to the data use. You need to ensure that it has statistical rigor. If it does not have statistical rigor, you need to have a good reason why. And we would get into that discussion in Reporting Limits 102. Well, I talked about, I should say, that the reporting limit is set by the data user and is tied to the data use. We want signal that is quantified with statistical rigor. If you were able to ask me a question, I bet one of the questions would be is, well, why don't I set my report limit at my action limit? So if I have a water quality standard or something that I'm working in a laboratory context, why don't I set my reporting limit there? And I hope I'm going to convince you today that that is not a good idea in 98% of the cases. And in the next course, Reporting Limits 102, that's where we would get into more discussion on that type of topic. So now introduced the 4 major quantitation limits, definitions, and terms. MDL, method detection limit. Remember, we are focusing in on that the signal is detected with that one. The level, and the first definition of the practical quantitation limit, where we move up in concentration level and our ability to use the data, as now we have quantified data. And the third definition of this definition, of the PQL, that 3 times the lowest point on the calibration curve, we have both quantified data with statistical rigor. And reporting limit different because we set that. It is not based on the method. All these other 3 are method dependent. So if you have, looking at total mercury in water, there's many methods for total mercury in water. And so you could have very different method detection limits, minimum levels, and practical quantitation limits for all the different methods. But with your project, you have one reporting limit, right? Because you're basing it on an action level. And reporting limit needs to be quantified with statistical rigor. So where we're at with our graphic slide, we're moving up in concentration. We've defined the method detection limit, the minimum level, and the reporting limit. And again, I put it in multiple graphics to try to, so that when you leave your desk today, hopefully you'll remember some of this. And I know that people remember things differently. Some people like pictures and some people like text. And so here it is, just again in text, with PQL as detected, ML, minimum as quantified, PQL as quantified, bringing it up to quantify with statistical rigor. If you make it as 3 times that lowest point on the calibration curve, you can also think of that as 3 times the minimum level. The minimum level is usually the lowest point on the calibration curve. And finally, our reporting limit, which is going to be based on our action limit, not set the same, but based on the data use. And it's going to be quantified with statistical rigor. So we've rounded out our graph here. And let me see if here's where practical quantitation limit would fit in somewhere. And the reason I don't put this one in is because of the fact that it has more than one definition. It's used, it has a lot of actually different definitions, and on a day-to-day basis I find it used differently, so I don't like to put it in, but I will keep talking about it throughout the talk, so when you're working and if it does come up, you will know how to assess what people mean when they say practical quantitation. Because remember, if they say it, you're going to ask them, how are you defining it? So what is this here? Why do I have an arrow between reporting limit and action limit? Why can't I just set those two the same? And if you're here, I talked about it a little bit. I had this graphic saying we don't want to set the reporting limit and the action limit the same. And if you are very interested in that and the ability to possibly put them the same, then that is something that we would be getting into in a lot of detail in Reporting Limits 102. And we'll talk about it a little bit today. I want to point it out to you because if this is something you're interested in, I want to know about that, and then we could develop this next course. You in another graphic, and this is a graphic that you might remember we're going to populate when we go through our in a minute here. To traffic, I kind of call this like the golden area or something like that. Or if, you know, this area really allows you to be protective then of your action limit. So I really like to see this area in a project or program design. I'm not saying that it's mandatory for a good project or program design, but I'm saying that probably 95% of the time it's a very good idea. So here's another slide with the definitions of the quantitation limits. We're done with the definitions at this point, and we are going to move on now to the surface water ambient monitoring programs reporting limit requirements, otherwise known as SWAMP. Has no required reporting limits. SWAMP has in its 2008 Quality Assurance Program Plan a list of reporting limits, but used within our program as target, and many of our projects within the program do not use those reporting limits. They're not applicable for their particular project, and they higher or lower reporting limits. But the reason for me to bring this up today is to tell you that SWAMP is currently revising all of its reporting limits, expecting the new tables to be out in late this year. And are interested in finding out about that when it happens, then you should make sure that you are on the SWAMP emailing LYRIS list. And I believe that links to that are located in this talk. But you could also email any one of my staff to get on that emailing list. This is one of those slides that I talked about earlier that has websites and information and phone numbers and things on it that I'm not going to go through, but you have it then as a reference if you should need it later, such as finding where the 2008 Quality Assurance Program Plan is and how to get to its reporting limits. But the main thing to remember about SWAMP is, or if you want your project or program to be SWAMP comparable, is that currently SWAMP does not require specific report limits and leaves that up to the project or program to determine those. These are just some screen captures of the SWAMP website, so you'll know where to go to find the information. And we also have a quality assurance website that's hosted by Moss Landing Marine Laboratories. And all of our documents and information are on here. So let's move on to something that I think now finally might be interesting for folks on the phone today, which is determining the program and project reporting limits. And unfortunately, I don't have a whole day to spend with you guys because I could easily spend a day talking about reporting limits and how to determine them. We only have an hour, so this is going to be a brief introduction. And if you want to get into this more, we can do another course, that Reporting Limits 102, or we can also talk to folks individually as well, or set up conference calls and things like that. So how do I determine program and project reporting limits? We said that it needs to be based on the use of the data. And we need to look at, well, how are we going to use the data in reporting? Are we looking at water quality standards? Are we looking at this in a regulatory context? Are we looking at this toward using our chemistry results with results of other testing, such as toxicity testing, which would change our reporting limits significantly probably from if we were looking at them for water quality standards? So the first problem in determining your reporting limit is determining the use of the data. And sometimes that's straightforward, and other times it's not, because we might want the data to be used by multiple sources. One of the other things I want to point out on the slide is that it's really important to understand that you cannot set reporting limits below the lowest level of state-of-the-art analytical capabilities. And we actually have, this actually happens, and that's why I'm bringing this up, not just with reporting limits, but sometimes also with standards. So remember, with reporting limits, that how can we set a reporting limit below the analytical capability is? Are we setting ourselves up then for some sort of failure, or is it that we need to push laboratories to lower their capabilities? And that happens specifically in the cases of when you want to look at toxicity testing. So, for example, Hyala, and you want to look at pyrethroid pesticides and sediments. We have a need to have very, very low reporting limits for the pyrethroid pesticides and sediments in order to tie that to toxicity testing results for Hyala. In this case, this is a good example to show where we have pushed the labs to lower their reporting limits and their capabilities to allow us to accurately assess those tests. So it's something to think about. The other thing to think about, too, is to remember with everything that we do in environmental science that there's a cost-benefit analysis that needs to happen, especially nowadays that we have funding drying up and every penny of that dollar has become even more precious. And so we really need to think about, lower our reporting limit, is giving us the most usable data? Sometimes want is maybe higher reporting limit so we can do more field samples, and sometimes we don't. Sometimes we do need that low reporting limit. And I'm not advocating raising your reporting limits. I mean, my background is in ultra trace metals speciation, so of course I'm, come from a very, very low level background in chemistry. But what I'm saying is that you need to think about it. Think about where this is all going. Do you need that? Tie it again to your data use, ensuring that your reporting limit is best for your data use. So let's look at this in sort of a flowchart manner, how we're going to pick our reporting limit. And again, please remember this is a super brief introduction to this, and I could go to really do this fully would probably take me a couple of hours and with several examples from different water board programs. But select a parameter. Obviously, that's our first step. Then we're going to determine our action limit. Now, most of the time, those are predetermined for us, maybe with a water quality standard or from the California Toxics Rule. Well, that action limit or our standard or whatever limit we're working towards, at that point, we can establish our reporting limit. Once we've established our reporting limit, we now need to check methods. Will any method support the reporting limit? We need to make sure that we actually have analytical methods that will support that. Finally, I want to get back to that actually. So what we might find in those cases is that we need to rethink our reporting limit if we don't find a method that supports it or the method is too expensive given our project scope. What we also find is that we might question the actual action limit. How did we determine that action limit? Is it the most appropriate to be working from? And finally, then, we're going to want to check with our labs on both our method detection limits. Remember, those are the signal that is lowest level signal detected, not quantified, but detected, and our reporting limits. When we are looking at methods and the laboratories, we really need to ensure we're going to be comparing apples to apples. So, through all those terms, method detection limit, minimum level, on practical quantitation level, reporting limit. I gave you guys the definitions. We went through that. But I'll tell you, they are used differently in different methods. Now, in EPA methods, they're generally consistent. But we'll compare an EPA method to, say, a USGS method or an EPA method to an ASTM method, or what if the laboratory has an in-house SOP? So when you are looking at these things in the methods, when you are looking at things like when it says minimum level or reporting limit, you want to ask yourself, how are they defining that term? And also when you're talking to the laboratories. So go through an exercise and actually do this quickly. We need to select a parameter, and today we're selecting total mercury in water. This is the parameter for our program or project. And the action limit is the California Toxics Rule limit for California Toxics Rule number for water, total mercury, which is 0.05 micrograms per liter. How are we going to establish our reporting limit if that's what's in the California Toxics Rule? Well, we want to be protective of that, right? So we are going to try to set our limit at 10 times less, our reporting limit. So we'll set it at, and I'm not saying 10 is the number to use all the time, but for the purposes of this illustration, I'm going to use 10. It gives us enough statistical rigor be able to use the data then in reporting and accurately, we feel within this size, accurately represent how close we are coming to that California toxics rule. So we're setting it at less than 10, which is 0.005 micrograms per liter. What we do now is then see if there's any methods available to analyze at that level. So what we're going to do is we are going to go on the NEMI, and I've put it down there in the lower left, and I understand from Eric that there is actually a webinar on how to use NEMI, which you can access through the website and listen to. It's been pre-recorded. So we're going to NEMI and type in mercury, total mercury in water, and there's about 10 methods for that. So what's our next step going to be in this process? We've established a reporting limit, a tentative reporting limit, and we found 10 methods that we can use for total mercury in waters. Excuse me. So here's what we came up with, more, but I didn't put them all into the table, from research. And remember, our reporting limit that we're working towards is 0.005 micrograms per liter. Off, we can see that the ones in the yellow aren't going to work. So this table, it starts with the method number, and this is information as you would, how you would see it on NEMI. Give the method number, it gives you the source, so we have some from EPA, some from USGS, and some from ASTM. It gives you the detection level, and well, the detection level, the source, and the method number are pretty easy to understand. And then it gets into this detection type. And this, you need to know what the definitions are, right? On the site, they don't provide a specific definition. So they don't have somewhere on the site where it says MDL equals what's in 40 CFR Part 136. So we have these different definitions, and already you can see we're comparing apples to oranges here. This is where I was getting into be careful. Let's look at this one. This method says that the detect type is RL, which we know means reporting limit. Well, how are they defining reporting limit for the method? Are they defining it as the lowest level standard run on the curve, which is what I'm guessing is probably the reporting limit? Because we're determining the reporting limit, right? Isn't that determined by the data user? And no definition on the NEMI website, so we'd have to go look in the method and see if there's a definition in there to make sure that they're not meaning what we might call minimum level or method detection limit. Then this method detection limit and then EPA method, so we can probably assume that that's following the 40 CFR Part 136 requirement for the methods, but necessarily, because some of the older methods, it's not up to date, right? So again, we want to be really careful. But here we have minimum level being used by ASTM. Now, if they're using the EPA definition of minimum level, then that would be equivalent to the lowest level standard run on the curve, which would meet our needs for this project, but would give a hint as to what they mean. And I don't know what this one is, RNGE. I think that must be, when specified, maybe that's what NEMI put in, but it's new to me. Maybe at the next webinar we can have had that figured out and add that to our definitions list. So you can see that a lot of times we're comparing this sort of apples to oranges thing, and it can be hard for the manager who is developing the reporting limit if you don't have sort of that baseline understanding of what they are. Because even if you do, even for me, I'm going to have to go in and pull the methods and look at exactly what they mean by all of this. But anyways, none of them in yellow are going to hit our reporting limit. We have two plausible methods that will work. And there's that the concentration line that I showed you before with our 0 on the left and going up in concentration to the right. And so we determined our action limit. which we're going to use as the California Toxics Rule, total mercury in water at 0.05 micrograms per liter. And we've set our project report limit at 10 times below that. Again, have to use 10 times below. That's just what we're doing for this project. And I found a really nice method we think that's going to work for this. EPA method 1631, there's a lot of labs, tons of labs in California that run it. It's not too expensive, and it meets our criteria for both the method detection limit and the minimum level because it's below our reporting limit. The reason that I really like this area here, because now we're protective of a standard. We have room for protection, whereas if we set our reporting limit if we set it right at the California Toxics Rule numeric number there, then we wouldn't have that level of protection of the standard. And go back to the practical quantitation limit, where would that fall in? The practical quantitation limit for this particular method would be 0.0015 micrograms per liter. So it would fall in between, obviously this is not to scale, it would be in between the minimum level and the reporting limit, and if you wanted to, you could actually pull your reporting limit down to that practical quantitation limit, because at that level you have both quantified and statistical rigor with your sample results. You remember the slide I showed in the beginning had more filled in on this chart in terms of then of the data, and we are going to get to that slide in about 10 more slides. So briefly go over working with a laboratory and reporting limits. And the big thing to remember is to ask them how they define everything. A lot of labs will say our reporting limit is 2, and what I mean by 2 is that's the lowest point on the calibration curve. And as you'll remember, that's quantified, but it's not quantified with statistical rigor, and you might want that statistical rigor. So you need to ask them how they're defining it. I mean, that's the main thing to remember, is to ask the labs, how are you defining and how do you come up with all of these determinations? When selecting a laboratory then, you're going to, as the project manager, be supplying them with an analyte list, right? You should be supplying them with your reporting limits. It shouldn't be you asking them what the report limit should be, and this happens time and time again. You, as the project manager, should be determining the project reporting limits based on the use of the data and supplying that to the laboratory. Now, this may be different if you're working at a very experimental level, again, say like that example that I was talking about with Hyalella, and you need to work with the lab to lower the reporting limits. But the vast majority of the time, you should be telling them what you need and see if they can meet that. Next, they should be supplying you with a list of their report limits, their method detection limits, and any SOPs and things like that. And if they can't supply you with that information very quickly, it should be a red flag. If they don't run method detection limit studies on a regular basis, that should be a red flag. So I want to point out that both parties should include any reporting limits and other quality control in your written forms of documentation, so things like the contract, which I'm going to talk about in about 1 minute here. I'm going to talk about it right now in documents for communication of reporting limits. How should your reporting limits be communicated? And remember, you determined those. They were predetermined before you started the study. Documents are really, honestly, the best thing as permits or contracts, because when it comes down to it, that's what people wallow. You can put it in quality assurance project plans, and I like to see it in quality assurance project plans. But the problem is that usually what we find is in practice, people follow contracts, or if it's in permits, certainly follow requirements in permits, but they don't always follow what's in their quality assurance project plan, even though they had to write one. You talk about it in your project planning and coordination meetings, and during your laboratory selection process, you should obviously be talking to the labs about this. The nice thing about putting it into, say, a permit or a contract is that it improves communication between the data producer and the data user, and it clarifies all the important details. So actually what I do if I have a laboratory working for me is I put everything in the contract, all the MQLs, all the QC, or I cite a document and I cite the tables that they need to follow, because again, I find that it's not followed if it's just in the quality assurance project plan. And so today we're focusing on reporting limits and MDLs, and I would certainly recommend that you put those in any type of document possible. I'm going to comment on reporting in the context of quantitation limits. So it's really important to understand these two terms when you're using reporting limits and when you're determining reporting limits. Non-detect is the first one. Non-detect is when the sample is less than the method detection limit, less than the lowest level signal. But probably more important is the detected but not quantified, because this is where we see as many non-detects as we see detected and not quantified. And this is where your sample has been detected. Remember that MDL is detected, but it's not all the way up to the ML yet, so it hasn't been quantified. And if we go back to that example that we were using before with our total mercury in water, in this area here we have the non-detect. When the signal has not been detected by the method, area where we have the detected but not quantified. So we have a signal has not been quantified by the system. In this case, the signal is an estimate. We have a signal that's quantified. And this is where we get into the signal of quantified with statistical rigor above the reporting limit. Let me point out that the practical quantitation limit, remember, if we define that as the lowest level point on the calibration curve, we have the quantified with statistical rigor. So an easy way to set reporting limits is set them at 3 times the lowest point on the calibration curve, because you have quantifiable data with statistical rigor. If you set the reporting limit all the way down to that minimum level, which is a lot of times when labs tell you what their reporting limit is, what they're really saying is what their minimum level is. You have quantified, but for your program or project, you may need quantified with that statistical rigor. Between the minimum level and the black line of practical quantitation limit there, I'm going to turn on the pointer so I can show you better. This is here, quantified. Signal to noise ratio be so great that the statistical variability around the signal might question the accuracy of that signal. So in other words, when you go to use it for reporting, the number is harder to argue anything beyond this line. These numbers here are estimates depending on the method in the laboratory and things like that. They're detected but not quantified. They can be reported, but you have to understand that statistically they're much harder to defend. This level, it's a little bit easier to defend, but again, we don't have that statistical rigor like we have moving forward from this point. And I'll get into that a lot more with the next training course, the 102. Today I have time. You need to know all those basic definitions like MDL and things like that to be able to get into that. So I've got 7 minutes and I'm almost done. New developments. Well, now that I've told you all this, I have some new news for you. US EPA came out with a report in December, and what that report found was that none of the procedures, as the MDL, and lots of other procedures like it's called limit of quantitation and limit of detection, none of the procedures consistently generated accurate results for the lowest concentration. So what I'm saying to you is that according to EPA's recent study, we'll say, oh, our MDL for, let me just go back a second here, our MDL for total for mercury in 1631 is this 0.002 micrograms per liter. What I found was the plus minus around that is actually much greater than we had thought. And so that brings into question then this, and all this, the results here and here, right? It's not affect these results. Moving right here. So now they've told you all these great, here's the MD, what the definition is, and here's what I found was there was one method that consistently generated accurate results. Now, I want to caveat that with their study was in itself lacking statistically because the real-world applicability of it is to extrapolate because they didn't use very many labs and they only used a few methods. So I don't know that we can say, let's throw everything out. But just so that you know that there is a significant amount of variability with all of these things below, I'm going to go back now, sorry, below this line. And I'm not saying don't use these numbers. I'm not saying don't use this stuff. This stuff is important stuff to use in here when you get a result in here, especially for certain types of studies. For other types of studies, I would say don't use any of these and just use more. Again, it goes back to that data use. If I put the link in so you can find that study if you want to read it, it's 80 pages. I'll let everyone know as things go forward with that, but what they found was they didn't have enough funding to continue with investigating this further. So in conclusion, I hope that you now have a general understanding of the common quantitation limits and terms, and you understand the difference between those quantitation limits. Understand that SWAMP has reporting limits in its QA program plan, but they are not required. To that very brief introduction of determining reporting limits and gave you a few tips on ensuring the labs can hit the reporting limits. I just want to reiterate this slide again. If there's one thing that you can take away, maybe as a picture in your mind to take this slide with you, I don't expect you to remember this slide, but remember we talked about that the MDL is a signal is detected, the ML, and that first definition of the PQL is quantified. That second definition of the PQL, where it's 3 times the lowest point, is both quantified and with statistical rigor, and that the reporting limit which you are setting is should be quantified and with statistical rigor. Showing this again to remind you that you might want to think about when you're setting your reporting limits, how are you being protective of the standard? So if you set that reporting limit right at your action limit, you may run into problems then for using the data and arguing that the water body or whatever it is that you're looking at is below that level. This is a quick, some thought I jotted down on a class that we could give on reporting limits 102. I thought it might be fun to go through some of the different water board uses and set reporting limits, so folks would have more hands-on, and maybe that would be good to do. I don't know if this might be better to do as an in-person type of a thing or a more interactive one where we allow people to talk during the presentation and have input. One of the questions that I get a lot is, can the action limit and the RL be the same? And we talked about that sort of golden area, the protection of the standard can be the same in some circumstances. You just have to understand how that affects usability, and we could go into that in another course. Can the standards be below method capabilities? What happens if you set some sort of standard? Like that there are in the California Toxics rule some numbers that are below analytical method capabilities, even at state of the art. And so what do we do with those? How do we work with them? And what do in our reporting limits when chemistry results are tied to other data such as toxicity testing? So for example, when you really need a super low number, or how do you set that up in your project? Or another question is, how do you use data from someone else's project, right, when you want to compare it to toxicity testing or things like that? It's not just toxicity testing. We have other ways the data intermingles, and how do we use that? Can we set a reporting limit on historical data when they didn't set it? Yeah. And so figuring all that out, what are the benefits to statistical rigor of a reporting limit that's 3 times the lowest point on the calibration curve? Do I always need to do that? Do I always have to have that statistical rigor? And what are the pluses and minuses to that? And then this is one I think is interesting, but maybe wouldn't be interesting to you guys, which is how to work with results that are between that method detection limit and the reporting limit, so that detected but not quantified. Can I use those? Are they considered estimated? When can I use them? When can I not use them? Can I use them as a first-line defense? Can I use them as second-line defense? So those type of things I think would be interesting to go into. And finally then, I need lower reporting limits in MDLs. What can I do? And there are sometimes cases where we can get labs to lower them, and sometimes it's just cost prohibitive to do that. So it's 12:30 and I am almost done, miraculously. We'll get help. Here's the Swamp Help Desk. Phone and email. This doesn't go to me. That's why I'm giving it out to everybody. Just kidding. This goes to Will Hagen. And do as if a question comes in, he routes it to the appropriate person in our group to answer. And this talk is being sponsored by the Swamp QA Help Desk, so you can thank the State Board Swamp program for this talk. And so if you had questions regarding this talk, you could forward them to this address, and we would, as Eric said, compile those if we get a lot, and maybe just send everybody an email like, here's the answers to the questions, or perhaps set up a conference call to discuss these. And I just put in our contact information in case you should want it. And finally, there's more sites and things like that for you to look at. So that's it, and I'm